So today we're interviewing Des McHale, who is a professor at UCC and also the world-leading expert on Boole, who wrote the biography on Boole. So Des, if I could jump right in, could I ask you what the essence is of Boole's most notable discovery?
Well, I'm probably biased because I'm a mathematician, and in fact a pure mathematician, a very pure mathematician. And my belief is that Boole's most famous discovery was the notion of what constitutes pure mathematics. And Boole looked on it as a set of symbols that you take, meaningless symbols. That's not derogatory. Symbols that don't necessarily have any definite meaning attached to them is what he meant. And then the laws of manipulation of those symbols. And pure mathematics actually consists of the output or the product that you get when you manipulate symbols. And the fact that the symbols don't have any meaning attached to them means that you can attach any meaning you like to them that's consistent with the laws, and that's what makes pure mathematics so useful later on.
Are there any other discoveries you might want to mention?
Well, of course, his most famous discovery is the fact that logic is a branch of mathematics, or some logicians would say mathematics is a branch of logic, but the notion that you can take logical statements, turn them into mathematical symbols, and then manipulate them in a mathematical way. That was a huge discovery. And of course, that was one of the steps that led to computing, electronics, and the digital technology. That once they're turned into meaningless symbols, you then don't have to interpret them, you can manipulate them and use them. And I'd say maybe the third magnificent discovery that Boole made was the idea that probability obeys exactly the same laws as logic does. And he discovered this between 1847, his first book, and his second book, which 1854, which was written in Cork, that probability obeys exactly the same rules as logic does. And this was a major discovery for which he gets very little credit. And of course, we know that electronics and the digital world dominate the 20th century and the 21st century, but I think probability does dominate our world as well. If you look at weather forecasting or the stock exchange or lotteries or anything whatsoever, the world is really run in a sort of fuzzy world that Boole created. And this is a discovery that I don't think he gets an awful lot of credit for.
So there were lots of mathematical fireworks coming out of his work, really, in different areas.
There were, because he invented invariant theory, and he also did some very good work with differential equations. But if you look at the essence of what he did, it's always about symbol manipulation. Reduce the situation to the bare essentials as far as symbols are concerned, and then manipulate those symbols. And the idea, I think, is to cut away the dead wood, that the context and the details aren't really important, that mathematics and pure mathematics in its essence is the manipulation of symbols. And funnily enough, long before I heard of Boole, this is what I felt myself. I felt this was the fun, this was the exciting part of mathematics. And when I was teaching this, I used to compare it to a game of chess. You have a chessboard, and then you have pieces on the chessboard. They have no meaning. I mean, the kings and queens and pawns, etc., they're just names that we give them. You don't actually need the board. You don't need the geometry of the board. You can just give the coordinates of each square on the board and write down the coordinates without ever drawing a single picture. And a good chess player is somebody who, first of all, accepts those rules, accepts those pieces, and then can actually do very positive things and creative things with defense and attack and do clever things with it. So I think when you're playing chess, you are actually doing pure mathematics. It's just in a disguised form. When you're doing bridge, when you're doing any card game, you are also doing pure mathematics in very disguised. And the enjoyment that people actually get from those games, I think, is the manipulation, is the mathematics that's actually behind it. But you wouldn't dare to suggest to a chess player or to a bridge player that they're just doing some mathematics. Let them be happy thinking they're doing something different or playing a game of some sort, but they are actually doing pure mathematics. And I would extend it further to music. If you look at music, the stave on the page is actually a geometric picture. It's a geometric diagram. If you take a great composer like Johann Sebastian Bach, I mean, they actually looked for beautiful patterns, beautiful variations on the page, but they were actually doing geometry of a certain sort. And then the geometry has an acoustic dimension, which makes it really very, very exciting. And remember that music was originally part of pure mathematics. It was part of the medieval quadrivium, and you actually had to do music to become a mathematician. And I feel very, very close to mathematics when I'm listening to music. And listening to musicians, I think they're talking about the beauty of a melody or the beauty of harmony. And it's almost the same type of beauty you get from pure mathematics.
Boole used to enjoy music a lot as well.
Enjoyed
Yeah.
music. Boole enjoyed music enormously, and when he was in Cork, he used to send over to England for his favourite pieces of sheet music. He liked Mendelssohn quite a lot. He liked Handel. He liked the classical composers. He liked oratorio. He would go to church on Sundays to hear the sermons and to listen to the music, not so much for the religious content of what's actually going on. And I think it's very, very nice that he enjoyed music so much. He when he came to Cork and got his first salary check as a professor, he bought a harmonium which he had installed in his lodging house and played it, much probably to the discomfort of the other boarders. But and then music dominated his life. He had music in his house all the time. And one wonders what he would have thought of electronic music or the electronic reproduction of music. I think he would have been delighted that you could reduce music to ones and zeros and that you actually play it and enjoy it, as is done now worldwide.
I find that, just to come back a bit about what you said about his in basically introducing pure mathematics to us, this new level of abstraction, that is such a big shift. Could you contrast this with what was before a little bit, or to the average viewer to understand? I mean, you gave the example of chess, but I'm just wondering, there were other mathematical theories there, say by Galois or other people out there. I hope I have the timeline right. But so they thought about something very specific when they were doing mathematics. Is that correct? They had one model in mind.
Yes, before Boole, I think people thought about mathematics as contextual. They thought we have a certain context for a certain problem. It could be, for example, the attractive force of gravity, that you write that as capital G times m1 m2 over r squared. And the formula was incidental, but it was in this particular context. But I think what Boole would have said was, look, let's look at this particular formula that we've got, see what the structure of the formula has got, look at it, strip away all the deadwood that's involved there, and look at it in the context of pure mathematics. And then the payoff is this formula may actually occur in lots of other areas of mathematics. And of course, even the formula I just mentioned there about gravitational attraction, the same thing happens in electrostatics. The same formula will actually happen for the attraction that two pieces of electrical equipment will have for each other. So there is nearly always a payoff. For some reason or other, there seemed to be resistance to this by a lot of mathematicians. And it's almost like when you move from primary school into secondary school and you go from arithmetic to algebra. You're very good at 2 plus 3 equals 5 and multiplying numbers. And then all of a sudden you're hit by 2x plus 3x equals, you're good, I don't know, I can't manage this. I don't know what x is. And I think what Boole says you don't have to know what x is. 2x plus 3x is equal to 5x no matter what x is, and you can put any variable x that you like in there and you'll still get the correct answer. Now that may not seem like a very big jump or a very big leap for us, but it was a huge leap in the history of mathematics. And I was reading only recently where the famous physicist or mathematical physicist James Clerk Maxwell said that Boole actually put his finger on the essence of what was going on there. It wasn't just Bertrand Russell who said this. I think it was known even in the 19th century that what Boole was doing with abstraction of symbols was vital to the progress of the subject. It made mathematics, A, interesting in itself, but B, more useful in a lot of other contexts. And in a sense, it's no wonder that Boolean algebra became the basis of the whole electronic revolution, because there it was, abstract and looking for an outlet. It got a similar outlet in probability theory. There are lots and lots of other areas where the same type of laws that you get in Boolean algebra hold. For example, in the mixing of colours, if you mix black paint and white paint, if you mix red paint and green paint, you get various other colours. So colour mixing actually satisfies the laws of Boolean algebra because x squared equals x. If you add or multiply x and x, you get x squared equals x. White paint and white paint gives you white paint. What strikes me as extraordinary was that all these notions were around and available since the time of Euclid. If you think back to Euclid about 2300 BC, they were actually the same. And if you look at greatest common divisor and least common multiple, the greatest common divisor of x and x is x. Here you have x squared equals x again. So anybody in the intervening 2,000 years could have said the laws of Boolean algebra can be traced right back to greatest common divisors and least common multiples, but nobody did. And of course, that's what genius is, I think, to spot something that's there, that's sitting, staring you in the face all the time, that nobody else saw. And I think Boole was one of the first people to see things like that. And I counted, I think, about a dozen different contexts for Boolean algebra, or the abstract set theory being the very obvious one, of course, or the Boole's algebra of classes, where it was there, was looking at people in the face, and nobody saw it except Boole. So I think that That's tremendous. And the power of abstraction in mathematics is really one of the great secrets of science. People are scared of it, but it's very worthwhile and very rewarding in the long run if you accept it, that you think in terms of abstract symbols.
What do you think Boole would have thought of today's digital world?
Well, this is quite a controversial question. What would Boole have thought of today's digital world? Obviously, he would have been very, very impressed, and he'd been very flattered by the fact that his algebra, manufactured out of calculus of logic in the 19th century, was the very basic algebra that underlies all of these devices. He'd have been impressed by computers. He'd been impressed by smartphones. I think, however, he might have been a little bit worried by the use that we're actually making of them. I think the first worry he might have was that I think it's making us lazy. I think we don't think as much as we did in those days. I think we're not as creative because we're letting machines do the work for us. And I honestly feel that the content of much of the stuff on the internet, I think he'd be appalled by that. I mean, the internet, I think, while wonderful, and I use it myself all the time, and it's certainly the greatest educational device ever invented, there's no doubt about that. But the amount of junk and the amount of rubbish and the amount of pornography, the amount of everything else is absolutely appalling. And if the world continues to slide down that way, I think we're going to have to restart. And then we're going to have to start looking at education again. But Boole would have been very, very flattered to think that as I think in astronomy, for example, he'd been very flattered with the telescopes and with space stuff and with the fact that the ones and zeros that come, from the planets as pictures are translated into digital pictures and then become real visual pictures. He'd been very flattered by that. He'd been very flattered by the amount of involvement of his ideas with the modern world. Now, remember, before Boole's time, mathematics consisted largely of arithmetic, little algebra, a fair bit of geometry, and a little bit of calculus, and that was about it. And minor variants of that. And he sort of started new areas of mathematics, like invariant theory, which he didn't involve himself very much with. But he started the algebra of classes, and he started a new type of algebra with new laws. Remember, old algebra was all based on the real numbers. They were just the laws of real numbers, and nobody dared question them. People like Hamilton and Boole did. Hamilton took away axioms, Boole added axioms, like x squared equals x. And this was a very daring thing to do. And of course, this opened the floodgates. And I think he'd been just as much impressed by the role that Boolean algebra plays within pure mathematics as he would by the amount of applications there have been to the electronic area. He'd have been very flattered again by the fact that his name appears so often in probability theory. But I think really if one had to pick one, the one I'd pick is that the influence he had on pure mathematics and the change he brought about. To see change from content back to the actual form of what's going on. And that was a big move, very simple move, looks by hindsight, but to me, one of the most exciting developments ever in the subject. I think Boole would have been flattered by the amount of attention he'd have got, but he wasn't an attention seeker. He would try to say, no, look, I just sort of wrote the stuff down. I had one or two very simple ideas. He'd have looked back to people like Aristotle and Bacon and Leibniz and Pascal and said, all the ideas were there in their work. And of course they were, but nobody noticed them, extracted them, wrote them down. And the confidence that Boole had in his own ideas is rather astonishing because he was self-educated from a poor background, didn't really have the help of anybody else. He had enormous confidence in the correctness of his own ideas and would contradict and correct people much more famous and much more eminent than he was with tremendous confidence, I think. I find that quite extraordinary. Even when he was quite young, even when he was only 21, he was prepared to challenge the accepted canons of the day and the accepted professors of the day and come up with his own ideas and say, right, this is correct. Now that takes some doing, I think. And yet he was not an arrogant man, but he was arrogant in a good sense as far as his mathematics and his ideas were concerned.
How much did religion play a role in his life, I wonder, or his ethics? In that sense?
Well, in the modern centuries, it is usual to sort of knock the influence of religion because so many people now are unbelievers. But in Boole's day, most of the scientists were actually believers in a god or in a particular set of tenets or whatever. But my belief is that Boole was very, very motivated by religion. I cannot say that he was a believer in the sort of orthodox sense of the word. He believed in a god of some sort. He was supposedly a Unitarian, which again had influences because one was the symbol for everything in his algebra. But I think he was very interested in religion as logic. And that is, write down the basic axioms of religion. And for him, they would usually be statements or quotations from the Old Testament. Accept them as logical statements, not necessarily true or false, but some things that were accepted. And then look at the logical consequences of those to come up with logically justified religion. And this was a very, very ambitious project indeed. And he spent quite a lot of his life doing this. It was never actually published. In fact, after his death, De Morgan decided, no, we won't publish this stuff because it might take away from the validity or the famousness of his work in logic. So, but it was a motivating factor in Boole's life. Now, remember when he was much younger, when he was 15, 16, he wanted to become a clergyman, probably in the Church of England, which was the faith in which he was brought up. But he didn't really have the resources, he didn't have the money, and of course, he was looking after his family. He had to take a job as an assistant teacher because his father's business had failed. So he was motivated by religion. He was probably more motivated by ethics than he was by religion, right behaviour. And he was very socially conscious. You must look after your fellow man, especially your fellow man who is either poor or ignorant or destitute or whatever. So I think religion was a big motivating factor in his life. And I think his notion that he wanted to explain the workings of the human mind was a tribute to the creator of the human mind. And my belief is that he regarded the human mind as the most complicated piece of matter in the universe. And I would agree. I think it's the most fantastic. We all carry it within us. Even the most stupid of us carry a mind within us. And the fact that this processing machine is probably faster than the fastest computer in the world, it really is quite marvellous. Now, I think Boole wanted to justify the workings of the human mind, discover them, and then, of course, eventually duplicate them in machine form or computer form. But religion, in his personal dealings, in his mathematical work, in his scientific work, was a big motivating factor.
How did Boole describe himself? I mean, people say he's a logician or a mathematician, or what did he think about his own work?
Well, first of all, how did Boole describe himself? What did he think of himself? First of all, he was a teacher. I mean, he made his living as a teacher, and until 1849, he was the owner of a school, I suppose the headmaster of the school, and taught various subjects within the school and taught within the Mechanics Institute, another place in Lincoln. He would also certainly describe himself as a mathematician at this time, because he actually had published papers in research mathematics. He had taught himself mathematics. So one might not want to give a single word to describe him, but certainly two of the words are teacher and mathematician. He was also a logician in the sense that he was interested in the workings of logic. He really showed that logic is a branch of mathematics. So he was certainly a logician in this sense, but mathematics, it was subsumed by mathematics. But when in 1857 he became a Fellow of the Royal Society, there was a column which said, renowned for or known for your prowess in what? Boole didn't write down teacher, didn't write down logician, didn't write down mathematician, but wrote down psychology. Now, whether this is, I don't know, pretentious or not, I mean, I wouldn't agree with this. I don't think Boole was a psychologist. He didn't make great contributions to the subject of psychology. But I think by psychology he meant I'm interested in the workings of the human mind and its influence on human behaviour. So he liked to think of himself that particular way, but I don't think he was. I mean, his great contribution was to mathematics in various forms, to pure mathematics, to the mathematics of logic, to probability theory. So history will judge him as a mathematician. He was a logician, he was a great teacher. Maybe he'd like to be thought of as a humanitarian as well, because he was very interested in various social causes. So there's always a difference between what a person thinks of themselves and what other people think of them. But I would first of all describe Boole as, I think he was a mathematician.
How important a part did Boole's wife Mary Everest play in his work?
Well, Boole married Mary Everest in 1855, and she came from a very famous family herself. She had grown up with Samuel Hahnemann in France, the founder of homeopathy. Her father was an eccentric English clergyman, and her uncle, Sir George Everest, was the man after whom the world's highest mountain is named. He was the Surveyor General of India. So she was a famous person. She was brought up learning French, which confused her a little bit, having to live in England afterwards. And she was interested in mathematics, certainly. But I don't think her mathematics was of anything like the same quality as Boole's. Boole, of course, was about 35, 36 when he got married. So he would have been regarded as a bachelor, had been interested in lots of different girls and romances before that, but usually fell out with his girlfriends for religious reasons. If they didn't accept certain tenets of religion, then he didn't want to continue the relationship with them. But I think she was an ideal and a good partner for her. She was eccentric. He was equally eccentric to him. She espoused homeopathy and hypnotism and phrenology and various other things that we'd regard as fringe medicine nowadays. But I think she was very important to him because she gave him tremendous confidence in what he was doing. She told him that she realised when he was working on the laws of thought that he was working on something very profound as far as humanity was concerned, and I think she was right. So she was the sort of confidence that he needed. Boole was fairly shy socially. I don't think he was a sort of socialite, although we found out recently that he did actually engage in a lot more social activities than we thought. But she was the person who sort of brought him into the real world. But I think they had a mutual interest in various areas. Now, sadly, this might have actually led to his premature death because I want to knock on the head the buckets of water theory that everybody seems to have. But she may have, and it's just a may, put him between wet sheets after the drenching he got in Cork, and he afterwards died of pneumonia. But apart from that, I think she was really good for him. The fact they had 5 daughters at 2-year intervals always strikes me as ironic. Somebody interested in probability should father 5 daughters consecutively, which is, I think, a 32-to-1 chance. But she gave him a family life. She gave him stability. He was very much attached to his parents in Lincoln, and after they had died, I think he felt very much alone. Her parents had just died as well, so she felt very alone too. They were married for only a very short period, about 10, 12 years, but during that time, I think she did change his life. She realised what he was doing was very important, and then she made sure that he didn't overtax himself. When she found him writing poetry, she would take the poetry, tear it up and throw it in the fire and say, your mind should be preserved for much greater things. They lived in a community. They lived in Blackrock and Ballintemple in Cork, and I think that they were part of what was going on, that they would be very much part of the upper echelons, I think. I mean, they would have had servants, they would have played music together, they would have lots of down-to-earth sort of things. But I think she gave him a family. I think that was very, very important. She gave him the stability that a family gives. Whereas the other great Irish mathematician, Hamilton, had a broken love affair at the age of 18 and never got over it, married somebody totally unsuitable and descended into alcoholism and had a much less happy family life. So don't underestimate the value of a happy family life to a working scientist or working mathematician. Gave him the sort of stability and confidence that he needed.
Could you tell a little bit about his daughter? I'm particularly fascinated with Alicia, but
yeah.
Yeah.
Well, Boole had 5 daughters, and they were all remarkable in their own right. At least 3 of them went on to become world famous. Alicia was his 3rd daughter, and she was a mathematician. Again, self-educated. She wouldn't have had formal schooling. And it's a complicated story because her brother-in-law, Charles Hinton, was the person who wrote the book on Flatland and the fourth dimension. And she became involved in the writing of this book and discussions of it and became interested in 4-dimensional geometry. Now, she looked at the cross-sections of the regular 4-dimensional solids, and this is a concept you can have only in your mind, and she did it by pure geometry, which is very difficult to do, and published a paper on it showing what these 3-dimensional cross-sections would look like. And put it away, didn't really think about it very much. And then about maybe 30, 40 years later, after she'd raised her family, she realised that somebody else had done the same work by analytical means, which involved numbers rather than geometric visualisation. And she wrote to him and found that she had got precisely the correct answers around the turn of the century. And this was quite remarkable, almost as remarkable as Boole's story himself, that a girl of 18 years of age who had no formal training, no formal schooling, would have been actually able to do this. So she was quite a remarkable person, and she was awarded an honorary doctorate for the work that she actually did. And it's quite. She worked with Coxeter, the famous geometer, and she invented the word polytope, which is now used quite considerably within mathematics. So quite a remarkable lady.
She was young, so could her father have influenced her, or was this all passed by the genes?
No, she was young. Her father died when she was only 6 years of age,
okay.
So she wouldn't have any mathematical contact with her father at all. Next daughter was Lucy. Lucy, again, had no formal schooling, no formal training after her father died. She went to live in London with her mother. She got a job in a chemist's shop or a pharmacist's shop and decided to go to classes and lessons to learn more about pharmacy. I went on to London University and became a chemist, published in chemistry, and became, I believe, the first woman professor of chemistry in the British Isles. So, I mean, that's raw talent, probably hereditary in some way, both from her father's side and her mother's side. But then the most remarkable daughter was the youngest one, Ethel Voynich, who had a career all of her own. She was born in the May of 1864. Her father died in the December of that year. So again, she would have never even met or seen her father consciously. She had a wild youth. She dressed in black for the mourning the state of the world, which is quite a romantic thing to do. She went to Russia. She had all sorts of adventures there. And then she came back and she wrote a book called The Gadfly. And The Gadfly is a bestseller worldwide in 30, 40 different languages. So, and she wrote several other books as well. She married Wilfrid Voynich, after whom the Voynich manuscript is called, the most famous piece of cryptography that the world has ever known that nobody has still yet solved. So tremendous adventures there. And I think the other two daughters as well, Margaret and Mary, I mean, they weren't terribly famous in themselves, but their descendants were famous as well. So Geoffrey Taylor was the son of one of them, and he was one of the world's most famous mathematical physicists. Geoffrey Hinton is descended from. The next couple of generations of the Booth family were almost as famous as their grandfather, George Booth. So whether you believe that talent or genius are hereditary, well, there's good evidence there to see that it certainly was in this case.
What were Boole's feelings about Cork and Ireland when he came?
Well, Boole, of course, was delighted to get a job in Cork, to become a professor without any background from secondary education or third level. Anybody would be glad to get it. I don't think he'd ever been to Ireland. He certainly had never been to Cork before. His initial reactions to Cork were quite good. He thought it looked nice. Of course, Cork depends very much on what time of the year you come here. He was staying in a house on campus and right beside the River Lee. But according to recent letters of his that I've read, I mean, he thought the place was a little bit dirty, and he thought that the people were not as well behaved as would be in England. Now, of course, you need a whole historical context for this. You're talking about post-famine Ireland. It's just about 2-3 years after the Great Famine, in which millions of people died and millions of people emigrated. But I think it was the whole notion that in Victorian England, people bettered themselves. Poor people were able to educate themselves. They were able to work hard. It's a bit ironic when his father actually lost his business. But Boole felt, why can't the Irish do the same? Why can't they sort of pull themselves up by their bootstraps and become better, become more prosperous? And I don't think he quite understood the position, the situation as it was. I don't think he also understood the Irish mentality. I think he never quite accepted that. And of course, the aspect of Cork that worried him most was the weather. I mean, it rained an awful lot. It was stormy a lot. And he was actually isolated in his house in Grenville Place, where he wrote the Laws of Thought. Downstairs was completely flooded, and he actually had to stay upstairs in his bedroom until the flood subsided. So he certainly wouldn't have been used to that back in England. He did not seem to be, although he was socially conscious and was a very charitable person. I've discovered that he gave a lot of money away to charity, to friends and to charitable causes. But he didn't seem to come to grips with the Irish situation. And I don't think he was as sympathetic as he might be to famine victims. I mean, famine was something he would not have known or experienced back in England, back in Lincoln. Here you had millions of people actually dying. And there were one or two incidents where he actually was cornered by skeletons, phantoms. People had come in from the countryside looking for food. And anyone would be terrified. He was particularly terrified. But it didn't seem to get him out actually fundraising for famine. And he wrote letters to the newspapers about the treatment of dogs and donkeys in the streets of Cork. That would be more his concern, I think, than the sufferings of human beings. But remember, he was a person of his time. I mean, you can't say that a person is going to be different from all the people around about them. And you didn't have the social consciousness then that you have now. But I think he was a humanitarian. But he was a humanitarian in the constructive sense. If you're a humanitarian, there's something that had to be done. You had to do something. You had to raise funds for something. You had to give of your time. And at the end of the day, it wasn't just helping people along and helping them to survive. It was helping them to better themselves. And that would be his outlook on, I'd say, the people of Cork and people around about him.
What kind of charities would he have supported?
He'd have supported social charities, workhouses, mechanics institutes, home for unmarried mothers, anything that was doing something constructive, anything that was doing something where a result could be seen at the end of the day. Just giving money to a beggar on the street is not something he would have done. In fact, he said that. He said, one soon comes to ignore the whine of the beggar sitting on the street. Even the starving child with a begging bowl held out, he could ignore that because he didn't feel it was in the context of doing something positive about it. He helped out with the workhouse in Cork with the infant mortality rate. He wrote a statistical paper saying how dreadful it was that so many children that were going there were dying before they ever got a chance of living. So I think you can see the type of area he would have supported, and the type he wouldn't have supported something just for the sake of supporting it. There had to be a result at the end of the day.
Where would we be today, or science and society be, if Boole would not have been?
Would somebody else have come along and done what Boole did if Boole hadn't done it? I think probably yes. It might have taken us longer. It might not be done in the same way, but maybe not. We might have reverted. We might have gone back to sort of very primitive ways. But the electronic revolution and the digital revolution now seem so obvious and so inevitable that I think it's probable somebody else would have actually done it. But Boole did it, and Boole did it at the particular time that he did. And remember that the work he did in logic lay there for about 90 years until Claude Shannon came along. And the way in which Shannon actually came along to it is quite extraordinary, because MIT had this policy that engineers had to do an art subject. And Shannon probably looked at French and German and thought that's a bit heavy, and then looked at philosophy and thought, yeah, that looks interesting. And during the philosophy course at MIT for engineers, there was a course in logic, a module in logic, and as he was doing the module in logic and probably doing it very carefully and very conscientiously, it suddenly struck him, hey, this algebra is exactly the stuff I need for switching circuits. And then he wrote his MSc thesis on that particular topic, and that looked like an innocent event, but that was the big breakthrough that brought Boole's work to public attention and really, in a sense, started the whole digital revolution. So I don't know. I mean, everybody talks about the ifs of history. It might never have happened. We might have gone off in a totally different direction. Instead of doing silicon, we might have done some other element like germanium, and we might have a germanium valley now instead of Silicon Valley. But who's to say? And, you know, we're now almost into the parallel universe theory where, I mean, it might have happened in a different way or to a different person, and that's another possibility. But it seems it did happen in this particular way.
How long do you think that Boolean algebra or the concepts will be taught towards the future?
Well, I think Boolean algebra will be taught in the future, just like I feel that ordinary arithmetic will be taught in the future, because it's absolutely basic. And now that it's become entrenched in computer science and the digital revolution, it's got to be taught. You've got to actually know it. On the other hand, there are a lot of people who are carrying very sophisticated electronic devices around with them who have no idea how they work. Just as there are a lot of people driving cars who have never lifted the bonnet. If something happens and they drive it in the garage and somebody else is programmed to do that. So I think it will be, but as part of mathematics, it certainly will be taught, because it's the basis of set theory and the algebra of classes. It's the basis of a whole algebraic movement, as it were. So it's got to be taught there. So I think the sad thing is that many schools no longer teach it. I mean, it should be taught in primary school. We could teach truth tables in primary school because they're very basic. They're very, very easy. I think children will pick them up. And it's a pity that children are becoming so sophisticated with the machines they're able to use and don't really have any knowledge of what's going on. And I think as part of algebra, as part of mathematics, as part of basic human knowledge, I think Boolean algebra will be taught for a long time to come. Boole actually revolutionised logic in the sense that if you look at old books on logic, and even some modern books on logic, that they're very wordy. They're very sort of full of words rather than symbols. So once you introduce symbols, it becomes mathematical. And as long as you know how to manipulate the particular symbols, then you're okay. I think a lot of people resisted this. They just didn't like mathematics, therefore they didn't like the manipulation of logical symbols. Now, one person who helped put Boole on the map was Lewis Carroll, because Lewis Carroll said he was very interested in what Boole was doing. He was a mathematician. He was also very interested in logic. He started to draw diagrams, different diagrams from Venn diagrams, but diagrams of his own kind, where the diagrams and the geometry would actually show you that the mathematical or the logical result was true. And then Carroll had the idea that it's very easy if you have a simple syllogism for the mind to process on its own. And the usual example would be, all girls are beautiful, Mary is a girl, therefore Mary is beautiful. Now that's very simple, and the diagrams there will consist of three rectangles, just one within the other, or three circles. But suppose you take 12 statements, in fact a bit like what Boole was doing with the Bible, and the statements would be something like, Australia is on the opposite end of the world to Britain. Kangaroos come out at night. I dislike motor cars with a certain cc capacity. Anything you like. Now, if you have a dozen of those statements, it's virtually impossible for any human mind, even probably the greatest chess player of the age, to see what the logical conclusion of those is. It's just too difficult to formulate them. Now, what Carroll actually did was to write down statements like that, translate them into Boolean algebra, and then come up with the conclusion. And I think the particular one that I remember was, I hate kangaroos. And this has been looked at by several people, and it shows you the limitations of the human mind. It shows you that with mathematics, you can actually overcome these limitations. But eventually, the algebraic limitations exhibit themselves, and you've got to get a machine to actually do it and show how to process the machine. Now, in a sense, Boole created this ethos, and many of the logicians, who would have been philosophers, remember, would have said to themselves, well, look, this is mathematics, this is computer science, this is logic, this is something I can't manage, I can't handle. And even to this day, you will find books on the history of logic and the history of philosophy who don't mention Boole at all. And it's almost purely out of fear out of mathematics. I mean, there is no doubt, there's no denying that Boole actually did make a big contribution in this particular area. But some of the people, being entrenched in their philosophical and verbal ways, I would say, just don't quite accept this and run away scared.
So I heard you have a potential link between Boole and Moriarty or Conan Doyle.
Well, let me tell you the story of my interest in Professor James Moriarty and his link with George Boole. I got a telephone call from the Cork Examiner one morning saying there was an article in the New Scientist magazine by Dr. John Bowers of Leeds University, and that he claimed, he didn't claim it directly, but he claimed there was a link between James Moriarty, the arch-villain of Sherlock Holmes, and George Boole. And of course I was very surprised about this because I'd been studying Boole for quite a long time, but this had never cropped up. But the more I read Bowers' theory, the more I thought, gosh, there's something in this. Now, he was very clever. He didn't say at any stage that Moriarty was based on Boole, but I think that was the implication. So I started to study this concept or this theory, and I've been doing so for maybe the last 20 years. And now I've got very, very strong leanings and very strong feelings towards the notion that Moriarty was based on George Boole. Now, it would seem very strange because Boole certainly, from what we can judge of him, was a good person, wasn't a criminal, wasn't a sort of arch-villain in any sense. But my belief is that it came about as follows. Conan Doyle did worship logic. Sherlock Holmes was the first person to be able to deduce who was the murderer, who was the criminal, by purely logical means. Quite impossible, of course, but I mean, this is what he did, and this is what his readers liked. And therefore, if he wanted to get some opposition for Sherlock Holmes, surely he would want somebody equal and opposite, like a vector v and a vector minus v, going in the opposite direction, but of equal length. And there was no point having the opposition a good person, because Sherlock Holmes is supposed to be good and on the side of good already. So let's make him bad and evil. Now, Sherlock Holmes certainly was very popular in the 1900s, and the author Arthur Conan Doyle would have actually, I think, attended soirees and meetings with Boole's widow, Mary Boole, and also in the company of H.G. Wells. He was another important figure in the story. And I think that I've heard about this marvellous, this wonderful, this saintly man who never put a foot wrong. And I think they conspired together and said, look, wouldn't it be nice to sort of turn this man in his head and make him an arch criminal? And remember, James Moriarty was a mathematician, taught in a small provincial university, wrote several papers like The Dynamics of an Asteroid and a paper on the binomial theorem and all things. And I've been able to relate all the mathematical works of Moriarty with works of George Boole. And certainly as a professor of mathematics, it would fit exactly. Now, there's only one drawing or picture of Moriarty done by Sidney Paget in the Strand magazine that looks so like Boole, uncannily like Boole. I think it's based on the only known photograph of Boole. And I've built up a whole series of coincidences and connections and links that I think really show that, I mean, what would I give it? I'd give it maybe 95% confidence level, which again is a Boolean thing to do if you're dealing with fuzzy logic or probability, in that there were other people mentioned as possible role models for Boole, but none of them fits exactly. None of them would have been the same. Simon Newcomb, for example, and Adam Worth. I mean, there might have been a little involved there. And of course, almost any fictional character will be based on perhaps several real characters. I don't think there's any case of a fictional character being based precisely on one person. But I think the person that fits most exactly for Moriarty is George Boole. And interesting, in his new book on Moriarty, Anthony Horowitz actually agrees with me. He says that Moriarty actually was a pupil of Boole's in Waddington and then came to Cork to be a pupil where Boole was actually professor. So he's got wind of the theory as well. And having somebody like Horowitz back it up is very, very gratifying, let me tell you. But at this stage now, I am quite convinced, or almost 100% convinced, to say 95% convinced, that Boole was the inspiration for Moriarty. And if that's the case, then Boole will become even better known than he is at the moment, because virtually everybody on the planet knows about Sherlock Holmes and knows about Moriarty. And I think the ultimate proof is that Doyle wanted logic and deductive logic to be really what was going on in the Sherlock Holmes stories. And who better to choose as your villain, even incongruously, than George Boole, who is the father of symbolic logic. I think that's really the link. But I've discovered an awful lot of other pieces of information that fit very well. And I don't know of any other candidate who fits the role better than Boole does.
And you mentioned H.G. Wells in the equation. How did he fit in?
Well, H.G. Wells came into the equation because H.G. Wells wrote a book called The New Machiavelli. And it was about Fabianism. And he had a go at two people in there, and the publishers were afraid that these people might sue him. So in the second edition, H.G. Wells changed the name of the bad people, of the villains in the book, to Boole. So you had Boole and his wife as the two people who were the villains of the piece. And most people say, oh no, that didn't happen. I've read the New Machiavelli, but it was the second edition of the New Machiavelli in which it happened. And the things he said about Mrs. Boole were absolutely awful. They really were libelous. Boole is dead at the time. And of course, he probably thought that Mary Boole would not sue him. But he said the most horrible and insulting things towards Boole. So I think he had a sort of a bone to pick, at least, with Mrs. Boole. He described her as a sort of poor author, eccentric, wrote various things like that. So certainly that was so that's the link I've made between Conan Doyle and Wells and Mrs. Boole. I don't know of any direct link between Conan Doyle and Mrs. Boole, except that he probably attended her house parties. And remember, Conan Doyle was born in the year in which Boole died, so he couldn't have known Boole. But I think they heard a lot about this very, very saintly man and says, okay, Wells was a known practical joker. He was certainly a person who had a go at people in the way, and an extraordinary man. I've read several biographies of him, and I think he was a very, very interesting guy. To read a Penguin book about Wells, and it said this business of the second edition. So I got the second edition, which is on the web actually, and the name of Boole is spattered all over me. You know, the way the yellow thing comes up when you sort of pick out a word on a computer book. And it's great actually finding it. I have a feeling they might have dropped it in subsequent editions. So it's just one edition. But the vehemence and the things he said about her and the physical descriptions, they're lurid. I mean, they're really... So you wouldn't do that just for a fictional character, and you wouldn't call it Boole. So that's a rare name. Boole doesn't occur very often, you know. How would I rate George Boole as a mathematician? Well, he did win a gold medal from the Royal Society for his paper on general method analysis. He introduced operator methods into calculus. He founded a new branch of mathematics in variant theory. He did very good work on differential equations and also plugged difference equations, which he gets very little treatment. Difference equations really came to the fore in the computer age of the 20th century. But for all these contributions, you would rate George Boole as a fairly good, not terribly outstanding, but a good, solid 19th century mathematician. Now remember, he didn't go to Cambridge, so he didn't get into the mainstream. He did publish lots of papers. But I think when you add the algebra of logic and the algebra of classes, I think that turns him into genius level. Because all these things were there. Everybody knows what a set of objects is. We've used the word set is the word in the English language which has the most different meanings. So nobody can say that they hadn't heard the word set before for a collection of objects. And I think when you think that he spotted something that was there, and especially the connection with ordinary language, the and the or and the not, that again everybody had known and everybody had used correctly for probably thousands of years, I think that takes genius, that you actually spot something. And I think it's comparable to Newton. Everybody had seen apples fall from the sky or apples fall from the tree onto the ground, and nobody asked what makes them do that. Why don't they stay on the tree when they get loose? And that he postulated the existence of a force, a gravitational force. Now that was there all the time. Nobody noticed it seems, except Newton, and then he formulated mathematically. I think what Boole did, who was also a fellow inhabitant of Lincolnshire, as Newton was, is comparable in mathematics to what Newton did in physics. That he saw this phenomenon and that he formulated it in mathematical terms. simplicity is there all the time, and that takes great genius. And I've tried in my own little sphere to do something similar in another area of mathematics, not an area of mathematics, but another area of human activity, and that's humorous. My ambition would be to look at jokes, write them down on the page, turn them into mathematical symbols, and ask the question, can I now decide if this joke is funny or not purely by mathematical means? And that's an even tougher thing than Boole tried to. I don't know if it's possible, but I've tried it and made some progress with it. And that's what you do. You look at something that everybody knows about, everybody laughs, everybody can sense whether a joke is funny or not. Very few people ask the question, why? What's the mechanism that's going on there? And I think that's what we need in education, is to get children to ask very, very obvious questions. And of course, if you did in previous generations, you got a clout across the ears from your teacher. Nowadays, you'll be told, well, now, that's not on the curriculum. That's not going to help you in examinations. Let's turn to something more useful than that. But that, to me, is the essence of education, asking crazy questions, maybe stupid questions, but most of all, obvious questions. And that's what Boole did. So what's the next obvious question to ask?
Okay. Could you tell us a little bit more about the link between Boole and De Morgan?
Well, Boole had many mathematical friends. He wrote to people and they vetted his work, and people like Thompson and Gregory, they actually helped him to publish his work earlier on. So it was since he was self-educated and out of the mathematical mainstream, especially out of the Cambridge mainstream, it was very useful for him to have mathematical friends. One of the earliest people he wrote to was Augustus De Morgan, who was professor of mathematics at London University. And De Morgan was very kind to Boole. And De Morgan had pretensions to logic himself. It seems the books on logic, the mathematical analysis of logic, and Augustus De Morgan's formal logic came out on the same day. But De Morgan very, very kindly and very, very generously acknowledged that Boole's notation was superior, and therefore he gave Boole the credit for having actually done this logic. But he was a great friend to Boole all his life. Boole called to see him in London quite a bit. Their families were friends. And of course, De Morgan's law and set theory, sort of A intersection B all dash is A dash union B dash, is a fundamental law in Boole's system as well. And if people don't think something like that's important, that's very important in the computer components industry, because it means that if you and or and not, then you can leave out either and or and just combine it with not and produce the same computer components. Now, how much does that actually help you in terms of simplicity, but also in terms of cost? So here's a piece of mathematics that has immediate practical applications. De Morgan also formed the third side of the triangle, Hamilton, Sir William Rowan Hamilton, Boole and De Morgan, because Hamilton and Boole didn't get on terribly well together, but De Morgan was friendly with both of them and would correspond from Hamilton to Boole in an indirect link, as it were. So he was very good for friendly relations between men like that. I think De Morgan was a very good catalyst. He was a very good mathematician in his own right. He was a popularizer of mathematics, but he certainly helped Boole and did not seek the limelight, which again is a very important thing to do. It's very easy for somebody to want to claim credit for inventions, even if they're your own inventions, but he didn't. And he helped Boole all the way along. After Boole's death, he helped to edit editions of Boole's books on differential equations and difference equations. And I think De Morgan was a true and a good friend to Boole, and a very generous friend. And of course, he was from a position of stability, and he had a university income and a professorship. I believe De Morgan was also Unitarian, as was Newton, or had Unitarian leanings. And it's very interesting to think of Unitarians playing such a huge role in 19th century British science and mathematics.
Who initiated, if it's possible to trace, who initiated the first contact? Because I know there's a whole correspondence between Boole and De Morgan. Yeah. Who was the first person was it Boole or De Morgan who
as far as I know, Boole was the person to initiate the correspondence between himself and De Morgan, because remember, Boole was unknown and Boole was dependent on making contact with outsiders. Who would have heard of Boole? Just a shoemaker's son, a schoolmaster in Lincoln. So Boole, as far as I know, would have written to them. And I think what he probably would have done he would have sent a piece of mathematics he had done to either Thompson, Lord Kelvin, or Duncan Gregory, or Augustus De Morgan. And then they would reply to him. And these people were very friendly. They were very nice. They were very generous. And of course, it pays to be generous, because you get ideas from these people, you collaborate with them, and you work with them. De Morgan was largely a writer of textbooks and popular articles on mathematics, and didn't do an awful lot of deep, fundamental new mathematics. But he was a great catalyst for Boole's work and various other people's work. But Boole, I think, was Well, he'd be a bit deferential. I mean, he would, a bit cap in hand, he would write, "Dear sir, I have the honour to be your obedient and humble servant, George Boole." But in his position, he had no choice but to be like that. But they were generous to him. And he was very quick to jump on bandwagons. And, he had to in his position. He had no other choice.
I mean, he went to the UK, but did he go to the continent, or did he...
As far as I know, Boole never set foot on the continent of Europe, which is astonishing because his wife had grown up in France. His sister spent a year in Germany. And I know that Boole once went to the cliffs of Dover to stand on the cliffs and look over and see France in the distance. So he would have actually seen it. Equally extraordinary is the fact that Boole never seemed to go to the United States. Now, there's no reason why he shouldn't have gone to the United States. He would have contacted some American mathematicians. So he went to Scotland, he went to the west of Ireland, but I think his entire life, as far as I can judge, was spent in the British Isles. Now, of course, this is the extraordinary thing about history, is that you come across, let's say if you came across a letter from Boole written from Rome, you've got to change your whole theory about what went on. So history is like that. It's not like mathematics that you can be sure of what happened in previous generations. If you find a piece of information or a piece of evidence or a letter or something like that, which makes me worry about the present day because we destroy all our emails. I mean, who keeps their old emails nowadays? And lots of vital information like that's going to be lost. But as far as I know, Boole was a home bird, and like mountains, like rivers, like valleys, like Scotland, like Connemara, liked Kerry, liked the, various parts of England, but never moved out of there, as far as I know. I'd love to find out if he did. I mean, if somebody has a letter or somebody has a piece of information showing that he was in Japan for a holiday, I'd be delighted to hear about that. Yeah.
So De Morgan always met him in London, or in
Yes, he would have called to De Morgan's house in London,
Okay.
and they would have probably stayed there as well. Yeah.
And you mentioned something about Babbage, a meeting with Babbage. I don't know if we can...
There was an extraordinary meeting with George Boole and Babbage. Boole was in Lincoln, went down to Cambridge. There was a great exhibition on. Babbage's analytical engine, the difference engine, was there and was working. And Boole came along, asked how it worked. And Babbage himself came along and showed Boole the workings of the machine. And I have letters from Boole to Babbage apologising that he wasn't able to stay longer. I think it was the time the college, Queen's College Cork, was actually burned down, so he had to get back and see actually what the situation was. But recently I've come across a longer account of that meeting done by Joseph Hill, who was a lawyer friend of Boole's, and he actually talked about the actual meeting of Babbage coming along. And it's very interesting that in this letter, Hill, who was a lawyer, and not terribly well versed, I would say, in science, except for his contact with Boole, actually said what I had said later on, as part of guesswork, that here was the founder of computer hardware and essentially the founder of computer software meeting in 1862. If they had both lived much longer, how different the world might be. Here was somebody saying this in 1866. So I think Hill could have got this idea, I think, only from Boole himself, or from Boole's wife. And it's extraordinary that they were thinking along those lines, that here was going to be a thinking machine in 1866. Almost, nearly 100 years before it actually happened. So that's vindication, and that just shows you how useful letters are. If you can find a letter where somebody writes something down. After Boole died, his sister, Mary Ann Boole, asked all his friends to write letters to her, biographical letters about what Boole was like, and this was one of the letters that Hill wrote. And it's a real mine of information, and it's absolutely authentic. I mean, here was a lawyer who'd be used to taking oaths. I don't think it... And anyway, he couldn't have made this up. I think this is something extraordinary. But the whole Babbage thing, of course, Babbage wasn't taken seriously in his day, wasn't supported. The government wouldn't give him any money to develop his machine. And if they had, again, history might have been totally different. We might have actually got this computer revolution 100 years before its time.